Hello, and welcome to Business Calculus, the Product Rule. We've spent a lot of time studying how to differentiate functions, and we're getting pretty close to knowing everything there is to know. So far, we have learned how to differentiate constant functions, power functions, a constant times a differentiable function, exponential functions, logarithmic functions, and the sums and differences of differentiable functions. What we're going to be doing the next few videos is adding the final few elements to our knowledge of differentiation so that we can be able to differentiate essentially any function that we know how to write down that involves polynomials, exponential functions, and logarithms. The first piece that we're going to add is the idea of differentiating the product of functions. Suppose we have two functions, f of x equals x squared and s of x equals x to the fourth power. We would like to differentiate the product of that first and second function, x squared times x to the fourth, which we know is equal to x to the sixth. Using our knowledge of the power rule, we know that the derivative of this function is 6x to the fifth power. But if we look at the derivatives of each element of the product individually, we see that f prime of x is equal to 2x and s prime of x is equal to 4x cubed. If we take that product, we get 2x times 4x cubed, which is 6x to the fourth power. Clearly, that is not equal to 6x to the fifth. This means that if we're going to differentiate the product of two functions, it follows a special rule, not a rule that's something like the derivative of a product is the product of derivatives. We have to do something more. And it turns out that that something more is what we call the product rule. If y equals f of x is a first function times a second function, and the derivative of the first function and the derivative of the second function exist, we say that the derivative of the product is equal to the derivative of the first function times the second function left alone plus the derivative of the second function times the first function left alone. This is your mantra. Remember this mnemonic device and you will never forget the product rule. The derivative of the product of two functions is the derivative of the first function times the second function left alone plus the derivative of the second function times the first function left alone. Let's do a couple of examples to drive the point home. We would like to start off by determining the derivative of this function f of x using two different methods. We're going to start off by multiplying it out and using the power rule and our sum and difference properties, and then we're going to apply the product rule to show that the answer is the same. So let's rewrite this by distributing 2x cubed. 2x cubed times 4x to the fourth is equal to 8x to the seventh power. And then 2x cubed minus or times negative 7x is 14x to the fourth power. Using the power rule on this expression, we get 8 times 7x to the sixth power minus 14 times 4x cubed, differentiating each power expression. Distributing our constants, we get 8 times 7, which is 56, x to the sixth power, minus 56x cubed. Next up, what we want to do is use the product rule to differentiate our function, simplify it, and then show that the results match. So we take the derivative of the first function times the second function left alone plus the derivative of the second function times the first function left alone. So we differentiate now 2x cubed and get 6x squared, and we're going to be multiplying that by the second function here, left alone. Then we differentiate the expression 4x to the fourth minus 7x to get 16x cubed minus 7. And then that is going to be times 2x cubed. Now we need to do some distributing before we can find like terms and combine them. Here we have 6 times 4, which is 24x to the 6th power, minus 42x cubed. And then we're going to be adding to that 16x cubed times 2x cubed, which is 32x to the 6th power, and then minus 14x cubed. We see we have a pair of like terms here and a pair of like terms here. 24 plus 32 is 56, x to the 6th, and then minus 42 minus 14, which is also 56. So we see that our two answers match, so if we have the product of two polynomials, we can choose to either multiply them out and then use the power rule to solve the problem, or we can use the product rule. Alright, let's do a couple more examples not involving polynomials where we must use the product rule. So, in order to calculate the derivative of our function, we take the derivative of the first function, which is going to be 4x squared, and then the second function is going to be e to the x. So, the derivative of 4x squared e to the x plus the derivative of the second function times the first function left alone. The derivative of 4x squared is 8x, and then we multiply that times e to the x. And then we're going to be adding to that the derivative of e to the x, which is e to the x, and then multiplying that times 4x squared. We see that it's possible to factor some elements of this expression, so let's go ahead and do that. We see that we can pull out a 4x e to the x, which is common to both of these terms, and that leaves us with 2 plus x left over. In our studies in Chapter 4, it's going to be very useful for us to have our derivatives in factored form, so go ahead and get in the habit of doing this. Alright, now we would like to differentiate the function 3x squared times the natural log of x, and we do it just like we've been doing. We take the derivative of the first function times the second function left alone, plus the derivative of the second function times the first function left alone. The derivative of 3x squared is 6x using the power rule, and then we multiply that by the natural log of x. We're going to be adding to that the derivative of the natural log of x, which is 1 over x, and then times 3x squared. We're going to go ahead and want to factor this expression too, just to get in the habit. And we see that after this second term here simplifies to be just 3x, we have a factor of 3x in both of our terms. So we're going to pull out a 3x, and then we're going to have 1 plus 2 times the natural log of x left over. Now what I would like for you to do is to determine the derivative of the following functions and simplify. For f of x, go ahead and leave it in polynomial form after you've differentiated. And for g of x, factor if necessary. Here are some choices for your answer. And thank you very much for listening.